I have a cosmic query. I have a cosmic query regarding the Higgs field. Is the current model of the Higgs field evenly distributed? Or could there be areas in space-time where the field is more dense?
This is a great question.
Ooh, I like that.
That's a really
could that mean
good-
that it's giving different masses
At
to
different-
particles over here than over there?
Yeah.
Wouldn't that be wild?
That'd be a messed up universe,
That's
though. What mass are you?
Yeah.
Well, today or yesterday? Right.
So a good friend of mine, Matt Strassler, guys should have him on. He wrote a wonderful book about this called Waves in an Impossible Sea, and it's all about the Higgs field. I'm glad that
You just like that impossible word.
I know,
That's
I love
all.
it. You'd be surprised how many books have the word impossible. So the Higgs field is what, and that's why it's impressive. Most people talk about the Higgs boson.
Right.
That's not what's so fundamental. The Higgs boson is just one instantiation, one creation moment of a particular fluctuation of this field called the Higgs field.
Right.
Yes, it could vary from time to time, and the most exciting thing is that it's what's called a scalar field. I don't want to get too technical, but that's the first and only scalar field that we know about. The other one that's postulated but not known yet to exist, we hope we can, shed some light on it, no pun intended, is the inflaton field. Those are scalar fields. They don't have what are called vector properties. They don't have properties. They only have a value. Like the temperature in this room is a scalar. It's a point. Every point in space, there's a value. 30 degrees Celsius. It's kind of hot over here. I'm talking. It gets even hotter. But the point is, it's a number at every point. But the Higgs field is a special case like that. The other types of field, like fermions, quarks, and other types of fields in photon fields, they are not. They have a sort of direction at each point in space-time. So the
Like
Higgs
a gravitational field has a value and a direction that it wants to pull you.
Yep.
Right.
So this just has a value.
Exactly.
Okay.
Okay.
Yep.
So
she's
why do we
definitely right.
care about that?
So if it did vary, it could be connected to the Higgs field and the inflaton. So that would be really exciting. It would say that the field that is responsible for giving inertia and mass to massive particles was in existence and coupled somehow to the origin of the universe itself. So maybe there's some connection between the masses of all particles that were, are, or ever will be, and this initial phase of the universe called the inflation.
Something
field.
we haven't
just don't
figured
know.
out yet because all the masses look pretty random.
Yeah.
I mean, yeah.
We
they're
have no fundamental theory that predicts why
of
this
the masses of particles in the
Yeah,
universe.
exactly.
Okay.
That's a great question.
All right.